Welcome. In this video we are going to look at how to do the analysis of junction field effect transistor, how to measure the transfer characteristics and drain characteristics using simulation using LTSPICE. Open LTSPICE, go to file window, go to new schematic and select the component. Okay, we need N channel JFET, NJF, click OK and fix it over here. And select, pick any JFET. I am going with the first one. Okay, and we need resistors on both the side. We are fixing the resistors. Okay, and we need the voltage source. So type voltage. Fix it at both the end. One is to control VDS and another one is to change VGS. And we need certain ground terminals. So fix it over here. Okay. Start doing the connection. Okay. Wire all the components. You can refer the circuit diagram. Connect all the component like this. Wire all the component. Yes. Now give the value to the resistor. Resistor may in the ranges of kilo ohm to 10 kilo ohms. Okay, you can vary the values. I'm going to fix it as 1K on both the sides. Okay, and rename this voltmeter as gate source voltage, right? So this is gate terminal, this is source terminal and this is drain terminal. So I am renaming this as gate to source voltage, RPS. Okay, and rename this voltmeter as, is not a value, we are going to rename the voltmeter as VGS. So it is not a voltmeter, voltage source as VGS, right? Okay. Before simulation, let us see how to simulate this. For example, let us simulate the transfer characteristics first. So here we are going to keep the drain source voltage as constant 10 volt and we are going to apply the sweep for VGS from 0 to minus 5 volt and we are see how the IT is getting varied. Okay. Yes. Now VDS we are going to fix it as a fixed value. So I am fixing this as a 10 volt and we have to give the sweep to VGS because we are going to vary the VGS, right? So type VGS, give linear sweep, start value 0, stop value minus 5 in the increment of 1. Okay. You can look at over here how the graph is 0, minus 1, minus 2, minus 3, minus 4 and up to minus 5. What we have to measure? We have to measure the drain current. So I am fixing a current clamp over drain terminal here. You can look at how we are getting the signal exactly. Okay, at minus 3 volt, this is VGS off condition. Okay, minus 3 volt, the ID will become 0. And at maximum, okay, that is VDS is equal to 10 volt. When VGS is equal to 0, we are getting IDSS as 8.5 milliamps here. Okay, the drain current saturation current is 8.5 milliamps. Okay, so this is about the transfer characteristics. Let us measure the drain characteristics also. So in drain characteristics, before that let us see how the drain characteristics we have to do. So drain characteristics you can look at for different VGS we have to kept and as well as we have to measure between ID and VDS. So in x-axis first we should get VDS, okay, and we also have to maintain different VGS. So we want to sweep both the voltages over here, okay. So in this case x-axis first VDS we have to kept it as a sweep in the first source, okay, and then we have to apply this too. So for drain characteristics measurement, I'm going to remove this graph. How to do this? Go to edit, okay, and first you save this for your copy and then do the drain characteristics. So I am now editing this, okay, I removing that, and I also remove the sweep also here, okay. Again I go to edit and I'm going to delete the sweep also here. So first in this case what we have to do, we have to sweep VDS first, right? So x-axis I need VDS, okay. So for that I'm going to start with 0 and I'm going to sweep, DC sweep. First source I'm going to take it as VDS in this case, okay. Fix this as linear and start value from 0 I'm going to start, stop value up to 25 volts I'm going to do, at the increment of 5 volts I'm going to do as VDS. You can look at over here 0, 3, 6, 9, 12 up to 25 we had taken the VDS voltage, okay. And again I want to sweep it, okay. So again I have to sweep, so click here. I want to sweep the second source. So the second sources I'm going to keep the VGS as constant values, right? So first I'm going to measure it for the condition 0 volt and then I'm going to measure the condition up to maybe minus 4 volts in the increment of minus 1 volt, okay, in the increment of 1 volt, okay. What I have to measure for this, I have to measure the ID, that is drain current value. So fix the clamp over drain current, okay, and give run, okay. You can see how it is, okay. At the maximum, that is minus 4 volt, it is 0, okay. Before that we are getting 3 voltages. This is for VGS is 0. I am getting approximately how much voltage over here, how much current ID over here, nearly 11.5 milliamps I am getting, saturation at 12 milliamps, okay. So you can see this point very clearly. So after this it is getting saturating here, the straight line representing saturation. So here in this point itself it is getting saturating. So here you can refer this red line, here it is getting saturating, okay. It is maintaining constant over this period, okay. So this is how we have to measure the drain characteristics of junction field effect transistor, and this is the maximum IDSS, yes. And in drain characteristics we can also plot certain regions, right? What are the regions we can plot it over there? So ohmic region, pinch off region, and breakdown region, okay. So here this saturation region we used to call this as a pinch off region, and you can look at the linear rise in the graph, right, between the VDS voltage and the ID current, right. So this linear case, okay, what is this linear increase in case we used to tell it this, when voltage and current are getting linearly increased, what we used to call it that? We used to call it that as a resistive region, right? So hence this region is named as an ohmic region, okay. So this linear rise region is called as an ohmic region, and the saturation region, so here it is maintaining at the same level, here we used to call it as a pinch off region, okay. After that, in some cases if we rise the VDS, the breakdown may occurs, okay. So here we had not shown that, okay. So this is about the drain characteristics of field effect transistor. So you can do the experiment practically, okay. So this time you can't able to do it practically, so you can simulate and submit your experiment results, okay. Thank you for watching. We'll meet you in the next experiment.